Hey, good morning. If you remember in my video 19, I was arguing about microtasking and paying by result. And I said there that if you want to do pay by result, in order to do proper management, then you have to do microtasking. And Benjamin, one of my listeners and readers, asked me a question referring to our management model. He was asking, do you still require planning sprints and releases? He's not sure how it works for us, but for him, clients always have deadlines, according to him, and they always need sort of minimum viable product. The question is quite interesting, and I decided to record a video explaining how the planning actually applies to microtasking, how they go together. And first I want to ask you, Benjamin, how do you plan? So how do you know what's going to happen in the future? How do you know when exactly the next release will show up and the customer will see the next portion of the functionality? And I can answer because I know how you do that. You put two programmers together, you do the sprint planning, or you do some sort of planning session. It depends on your management model, but they ask them when it's going to happen. When do you, John, will deliver your functionality? When Mary will finish that bug fixing? When? And they give you numbers. They predict somehow, they guess when the functionality will be ready, and then they promise you something. And then you put those numbers together, and then you go back to your customer and you promise that people when the functionality will be ready. Is it a good approach for estimating and planning? I don't think it's based on facts. It's more like emotions based, because people are not really good in planning and management. They're programmers, they're technical engineers, they're good in writing code, but they're not really good in predicting when that code will be finished. And that's why they make mistakes, and that's why the management, in order to deal with those mistakes, use different padding approaches. When they just get the numbers from programmers, then multiply it by 3 and call it a realistic estimate. You know how it works. In microtasking, this is not the case entirely, because we don't ask programmers how much they will take, how much time will it take to finish some functionality or to fix some bug. We delegate microtasks to programmers. And each microtask has a very limited and very small micro budget. In our case, it's half an hour. So we give hundreds of tasks to programmers, and each task is very small, and they deliver them very intensively. They deliver multiple results, multiple tasks per day, each programmer. So when the team is large, let's say 20, 30 programmers there, then each programmer who is actively working can close, say, 5, 7, 8, 10 tasks per day. And that means hundreds of tasks per day for a large, actively moving forward project. And then using this large data set, the computer, the artificial intelligence, which we have, the algorithm, can predict when it's going to happen, when the next functionality will be delivered, when the next feature. How do we do that? We use basically 3 inputs. You remember my recent video about artificial intelligence. The artificial intelligence is just a computer which gets some input and delivers some output. In our case, we have 3 inputs. First of all, we pay attention to how intensively tickets are being reported. So how many tickets per day the project produces, including bugs, puzzles, which we have for sort of the puzzle-driven development approach, and new feature requests, which are coming from the customer. They all together go into the pipeline, and if we calculate how many of them we get per day, we get some graph, we get some dynamics of what's going on with the tickets. Looking at this graph, we may decide where exactly the project is located right now on the overall time scale of the entire project, on the entire scope. So the computer can predict, looking back to previous projects, comparing this one with previous results, where on the timeline, where on the scope completeness we are located right now. The second input which we use is the average speed of ticket closing. We know approximately how fast we close tickets in this particular project. Per project, per programmer, there are different metrics, but still, the overall, it's the speed of closing those tickets. The number depends. In different projects, it goes from 2-3 days for fast projects, up to 7-10 or longer for projects which move forward way slower. But this is the number we get. We know approximately how fast we can close tickets in this particular project. And then we have the third group of inputs, which are given to us by benchmarking the current project or current set of developers with our previous results. We know approximately how fast that developer was closing tickets over the last year, or how fast that similar projects of similar size were closed or were completed or were delivered per day in our previous history. So there are three inputs we get. We know the position on the graph, we know how fast we move forward, and we know how far or how close we are from our previous results. And then the AI starts to work, the algorithms, the artificial intelligence. We just put all these numbers together and we predict when approximately or when exactly will we complete the next set of functionality, the next group of tickets. And we make the prediction, the computer makes the prediction. We don't ask programmers how fast they will deliver. We don't need that information. We know how fast they deliver. We don't need poker planning sessions. We don't need to ask them to estimate anything. We know how fast they complete their tasks because we have the history and we know how they move forward. And the risk of mistakes being made by the computer is very small because tasks are small, because we deal with micro tasks. If tasks would be large, if that would be like a week of work per each task, then the computer would not be able to estimate accurately because each task would be very different from previous ones. But we deal with micro tasks. They're all small. They're all half an hour. So the cost of mistake the computer can make is not very high, taking into account that there are many micro tasks. So what are the key factors which affect the accuracy and the preciseness of our estimate? There are basically four of them. First of all, the larger the experience, the longer the history of work, the more projects we have to benchmark with, the better. If we know the programmer for 2-3 years, then of course we can easily predict how fast that person will deliver. If we know the programmer for a few weeks, then we are in a dark zone. We don't know exactly how fast that person will complete his or her tasks in that particular project. So the larger the experience, the more projects we completed before, the larger the database, the more accurate is the estimate. In case of Xerocracy, that's a great benefit of the platform, because when you join Xerocracy as a customer, then your project is immediately being compared to hundreds or thousands or millions of projects we've done before, and that gives you a very valuable information, very valuable data for the estimate. And you don't need to know that data, but the computer, the AI, gives you the comparison and tells you that your project most likely will be completed in 3 months. And that estimate is not based on our guesses, it's not based on the predictions made by a few individual programmers, but it's based on a huge fact data set. The second factor is the bigger the project, the easier it is to estimate the future, because it has more micro tasks. If the project is small, just let's say 20 micro tasks, we don't really know exactly when it's going to happen because the amount of work is very small, and that's why every individual mistake made in one estimate, made in one particular micro task, will seriously affect the entire picture. But if we have 1,000 micro tasks in the past and 2,000 micro tasks in the future, then the accuracy will be quite high. So the larger the project, the easier for us to estimate. The factor number 3 is the smaller the tasks, the better. If you work with bigger tasks, not micro tasks like we do for half an hour, maybe 1 hour sometimes, but if you work with larger pieces like a week of work or 2 weeks of work, of even a day of work, then again, the cost of one individual mistake is too high, because the complexity of tasks, of each task, is very high. And when tasks are larger, the complexity is larger, it's more difficult to predict what exactly will happen there. With microtasks, we can predict. We know that one microtask approximately is being completed by Jeffrey in approximately 3.5 days. All tasks are more or less the same in size because they cost the same, and we know Jeffrey for a few years. We know that that person will not make large mistakes and will not spend 3 weeks doing something which actually costs him half an hour. So that means that we can predict that if we have 100 tasks in front of us and all of them are assigned to Jeffrey, then approximately the entire scope will be completed in, say, 27 days. That's more or less accurate prediction. If instead of that we have 2 tasks for Jeffrey and we know Jeffrey for just a few weeks, it's absolutely impossible to predict when Jeffrey will complete, or even at all it will be completed, because we don't know Jeffrey and the size of the task is too big. We don't know what may happen inside such a large piece of work. Maybe it's incompletable at all. Maybe it will take a year of investigation, of research. So the smaller the tasks, the easier to predict. And the factor number 4 is the more programmers we have in the project, the better. If there's only one developer there, then some personal factors may affect the entire picture, because the person may not be in a good mood, the person may suddenly go on vacation, the person may have some unpredictable personal difficulties in being motivated to complete the work. Different scenarios may happen. But if we have 20 programmers and 20 of them are working together as a pool of resources, then their individual problems will not affect the entire picture. And that means that the prediction, the estimate, will be more accurate. So there are 4 factors. We put them on together. If all 4 of them play in our favor, if we have large experience, if project is quite big, if we deal with microtasks, and we have a big number of programmers, then our estimates will be pretty accurate and way more accurate than any other informal estimation approach can produce. So microtasking, as you can see, I hope I proved that to you, that it not only helps programmers to be more motivated, not only helps management to pay them by results, but also helps everybody to see the future better. That's the beauty of microtasking. Thanks for watching. Stay tuned. Bye-bye.